Hi and welcome to the second video on homeostasis. Today we're going to be looking at thermoregulation. But first a quick recap. Okay, so we should remember that homeostasis basically means staying the same. It was introduced, or the word was introduced by Claude Bernard, and it basically means maintaining a constant, stable internal environment. So why do we need to maintain a constant temperature? Well, the most important reason is enzymes. So enzymes are biological catalysts in that they speed up chemical reactions. They also have an optimum temperature, which is approximately 37 degrees. If our core temperature gets too high, we suffer from hyperthermia, and the enzymes start to denature and no longer work. If our core temperature gets too low, then we suffer from hypothermia, and the enzymes' rate of reaction starts to slow down. Now notice I've mentioned core temperature. Your core temperature basically is your head, your thorax and your abdomen, because that's where most of the important organs, the vital organs, are stored. Your extremities are things like your fingers, your toes, your nose and your ears. Those temperatures can fluctuate more. Okay, so you've got a quick recap of a negative feedback loop. You've got your normal internal environment, which is stable. You've got a change detected by receptors to that environment. Signals are then sent to the control center, which is usually the hypothalamus, here and here, which sends signals to the effectors to decrease or increase to bring the body back to its normal environment or to its normal state. So we're going to have a look at how thermoregulation takes place now. So here you've got your normal stable internal environment, that's 37 degrees Celsius, and let's say you get too hot. So receptors detect those changes within the skin and also within the blood, and information is sent to your hypothalamus. Now, your hypothalamus then sends a signal to the effectors to bring about three changes. The first one is vasodilation. Hairs on the skin start to lie flat, and also increased sweat production. So if we take a close look at that, you can see here within this diagram, here you've got the sweat gland production, so you can see that sweat has been produced, and what that does, it increases heat loss through evaporation. For D, the muscles here, they start to relax, thereby forcing the hair safe down flat and closer to the surface of the skin. What that does, it reduces the amount of still air trapped in between these layers here. In other words, it promotes the movement of air and thus aids heat loss through convection. For F, you've got vasodilation, and what that means is that these capillaries here, they divert blood upwards towards the surface of the skin, where it can lose heat through conduction and also convection as well. When you get too cold, receptors within the skin and also within the blood once again detect that change, send the information to the hypothalamus, which sends information through the effectors to bring about changes as well. These changes are decreased sweat production, vasoconstriction, and also shivering as well. So if we have a closer look, you can see that if we start off with A, these erector fili muscles, they contract, thereby lifting the hairs on your skin, and therefore it traps air in between them. For C, which is vasoconstriction, the capillaries which are close to the surface of the skin, they get blocked off, and blood is diverted back deeper into the skin, thereby conserving heat. And as you can see here, that sweat production has stopped completely.